free body diagram in 3 dimensions. The summation of equations for equilibrium in 3 dimensions, which are sigma f equals to 0, which means that and sigma m equals to 0, which means that the summation in these equations includes the effect of all forces on the body under consideration. We learned in the previous article that the free body diagram in the 2 dimensions is the only reliable method for disclosing all forces and method which should be included in our equilibrium equations. In 3 dimensions, the free body diagram serves the same essential purpose as it does in 2-dimensional and should always be drawn. We have our choice either of drawing a pictorial view of isolated body with all external forces represented or of drawing the orthogonal projection of the free body diagram. Both representation and illustrated in the same sample problems at the end of this article. The correct representation of forces on the free body diagram requires a knowledge of characteristics of contacting surface. The characteristics were described before for 2-dimensional problems, and their extension to the 3-dimensional problems is represented here in some picture. The representation in both 2-dimensional and 3-dimensional will be used in 3-dimensional analysis. The essential purpose of the free body diagram is to develop a reliable picture of physical action of all forces acting on a body. So it is helpful to represent the forces in their correct physical sense whenever possible. This way, the free body diagrams becomes a closer model to the actual physical problem than it would be if the forces were arbitrarily assigned or always assigned in the same mathematical sense as that of assigned coordinate axes. These pictures provide some example of contact surfaces that we use in 3-dimensional problems. The first, consider this picture as the first example of contacted surface. Consider this member in contact with, as right also here, member in contact with a smooth surface. Or ball supported member. In this case, force must be normal to the surface and directed towards the member as shown here. There is no resistance in the x and y direction because we assume that it was a smooth contact. The second example is member in contact with roof surface. 2. Member in contact with roof surface. In this case, the possibility exists for a force F tangent to the surface friction phase to act on the member as well as a normal force N. We have a force N as a normal and the contact friction force that's shown here. This friction force can be two component in x and y direction, and the resultant are Fx plus Fy. Member in contact with the roof surface. The next example is roller or wheel support with lateral constraint. Roller or wheel support with lateral constraint as shown in this picture. It is obvious that we have a normal force in the roller support and also a constraint in the y direction. There is no constraint in x direction because it can freely move in x direction. So we have two components P and N. Roller or wheel support. Ball and socket joint is the next example. For ball and socket joint, as shown in this picture, there is three forces in x, y, and z direction, but there is no resistance about the rotation in the ball socket joint, so there is no moment in the support free body diagram. The next is the fixed connection. The fixed connection is different from the ball and socket joints, and the differential is the existence of moment in each axis. Consider this picture for more description. Fixed connection. As shown in this picture, more aware of the forces in the point of connection in this support, there is also some resistance about rotation in each axis. So we have Rx, Ry, and Rz, more aware of Mx, My, and Mz. In this type of supports, the free diagram is provided in this picture. The next example is truss bearing support. 6. Truss bearing support. As shown, there is no resistance about rotation in the about y-axis, so we don't have any resistance, moment resistance about y, but we have two rotation resistance about x and y-axis. So we have three force and two moment in this type of support, and it should be used in the free body diagrams. In these examples, The correct sense of all nouns Rx and Ry may be known or perceived to be the sense opposite to those of the assigned coded access. Similar combination can be choose for the other samples. The sign of each forces can be choose arbitrary, and after calculation we can realize that our assumption is true or not. If the sign of our calculation appears with minus sign, it says that our arbitrary chosen direction is not true, and we should opposite the direction of the chosen supporting forces for the free body diagram. The next section is about the categories of equilibrium in three-dimensional cases.